Hi, I'm Richard C. I'm a math tutor at Wyzant. I'm answering a question submitted by a student. This is a calculus question having to do with the volume of a cube. And so that's where we're going to start. We'll start by writing the volume of a cube, write the formula for that. So the volume of a cube, if each edge of the cube is E, we'll just call it E, it's just going to be E cubed. That's all it is. And I'm not very good at drawing in 3 dimensions, but just imagine a cube and all the edges are the same. So this would be E here, and E here. The length and the width and the height would all be E. Okay. Now our cube is increasing. It's getting bigger and bigger. It's a magic cube. Try to imagine I don't know, maybe a balloon in the shape of a cube. No, that's kind of far-fetched. Just try to imagine a cube that's increasing. So the volume depends on time. And so that's what we have to, this is going to be E at a given time. See, E is also a function of time. So that's the key insight here. So I can write this E of t quantity cubed if I wanted to, just so that you could see this is a function of time. So v prime, just differentiating here, is going to be 3 times E of t squared times dE dt. Or instead of writing dE dt, I could write E prime here, if that is easier for you, depending on the notation that you prefer. Okay, so this is just chain rule here. So now we're ready to fill this in. So let's start filling it in. We want to know how fast is the volume increasing. The edge is 10 centimeters long. So d prime of t, or instead of mixing notation here, let me just do it this way. Sorry about that. I should just stick with the same notation throughout. Okay, so dv dt is equal to 3. And we're told that the edge at this point in time is 10 centimeters long, so I'm just going to be 10 squared. And we're told that the edge is increasing at the rate of 3 centimeters per second, so that's dE dt. So that's a 3 there. Okay, so this is dE dt is 3. The length of the edge at that point in time, that the edge is 10, and then the 3 is the 3, so that's it. So that's just 900. And the units are going to be centimeters per second. And that's all there is to it. So it's fairly simple. if you just have to realize that the length of the edge is a function of time, and therefore the volume itself also is a function of time. And then all you have to do is take the derivative with respect to time to figure out how fast the volume is changing at a particular time. And that's all there is to it. So it's a fairly easy one. It's called a related rates problem. You're going to see a lot of these, and they're going to be, usually they're a little bit harder than this one. So I assume this student is just starting this topic. And if you want to see related rates problems, there's several that I've done on Wyzant, and in general, there's tons of them out there on the internet for you to look at. Okay, so I hope that was helpful to you. I'll see you again next time. Bye bye.